Welding is the process of fusing two metal parts together by heating them to a molten state using a gas flame or electricity. The welding process heats the edges of two workpieces, called the base metals, to their melting point. The molten metal from the two pieces combine. The two pieces become one when the molten metal cools and becomes solid. A filler metal is sometimes melted into the weld. Filler metal is similar to the metal being joined. It strengthens the weld by filling the gap between the two pieces of metal. Welding is an important fabrication process because it is a stronger method of joining metal than bolting or riveting. It is fast, easy, and can be done in a production facility or in the field. Welding is also one of the cheapest ways to join metals. In welding, the two pieces of base metal actually become one. A well-executed welded joint is stronger than the base metal because of the extra strength added by the filler metal. Welded joints are not easily disassembled. This is a disadvantage if there is a need to separate the welded parts for maintenance. The piping shown here is bolted together instead of welded to permit disassembly. Another disadvantage of welding is that it creates a rough seam that may require grinding to make smooth. Welded joints are less attractive than other types of joints. Making them attractive requires added work. Welding is widely used in both construction and manufacturing. Automobiles, airplanes, trains, farm equipment, and construction equipment are all made using the welding process. Welding is also used in fabrication shops, where parts such as trusses and frames are assembled before being shipped to a construction site. There are many different types of welding. One of the oldest and most common types is oxyacetylene welding. Oxyacetylene welding uses a simple system of two gas cylinders, a torch, and a filler rod. Oxyacetylene welding is in a category of welding processes called oxy-fuel gas welding. The acetylene is the main fuel for the flame. Pure oxygen is added to increase the flame temperature so that it can partially melt the workpiece. The operator starts the oxyacetylene welding system by turning on the acetylene gas, lighting the torch, and adding oxygen until the flame is hot enough to begin welding. The flame is applied to the workpieces until molten pools form on the edges of both pieces. The operator moves the flame in a gentle swirling motion to help mix the molten metal from both sides as the puddle is lengthened along the weld line. In some cases, a filler metal is added to the weld to fill the joint completely and add strength. Filler metal is similar to the base metal and is shaped as a rod or wire. The filler rod is dipped into the pool of molten base metal, causing it to melt and mix with the puddle. The melted metal mixture flows into the gap between the two pieces of base metal and strengthens the weld. Nitrogen, oxygen, and hydrogen cause weld contamination. These gases are absorbed from the air into the weld when the weld is in a molten state. These gases are then released when the weld cools, causing small holes or pores in the weld. Weld porosity can be a reason to reject the weld because it weakens the weld. Oxyacetylene welding usually avoids the problems of contamination because its flame burns off the gases that cause contamination. Oxyacetylene welding is low cost, it uses no electricity, and it is not sensitive to wind or drafts. These features make oxyacetylene welding the most commonly used method of welding in outdoor and other non-industrial settings. But oxyacetylene welding also has disadvantages. It requires an explosive combination of gases, is not easily automated, and is not effective with thin metals under 3 millimeters, about 1/8 inch. The reason oxyacetylene welding is not used on thin metal is because the torch gets so hot that thin sheet metal tends to warp. However, oxyacetylene welding is still versatile. It can be used to weld many types of metal including cast iron, steel, chrome moly steel, and cast brass. Oxyacetylene welding has become less popular in industrial applications over the years, but is still used extensively in field and shop work. Exposure to gases in the air can contaminate a weld. Welding is fast, easy, and can be done in a factory or in the field. Oxyacetylene welding tends to warp or melt which material? Which of the following characteristics applies to oxyacetylene welding of metal? Filler metal strengthens the weld by filling the gap between the two pieces of metal when welding. The permanence of a weld can be viewed as a disadvantage if it is desirable for a joint to undergo which process? Oxyacetylene welding can be used to weld cast iron, steel, chrome moly steel, and cast brass. Shielded metal arc welding, or SMAW, creates an electric arc between an electrode and the workpiece. It is called stick welding because the electrode looks like a stick. A SMAW system consists of a welding machine, 2 leads, an electrode holder, and a covered electrode. In SMAW or stick welding, the welding machine produces an electric current that runs through the 2 leads and workpieces when the electrode is brought near the workpieces. The current creates an arc as it jumps the gap between the electrode and workpieces, completing the circuit. The arc produces a temperature of about 3,593 degrees Celsius, or 6,500 degrees Fahrenheit, at the tip. The heat produced melts the workpieces to join them together. After the arc is established, the electrode itself melts, providing filler metal to complete the weld. The electrode is a rod made of filler metal, similar to the one used in oxyacetylene welding, except that it is covered with a substance called flux. Flux is a cleaning agent that protects the base metals and filler metal from contamination during the welding process. When heated, the flux turns into a gas that shields the weld from contaminant gases in the air. SMAW has several advantages that make it suitable for use in a wide range of environments. It is portable, inexpensive, and it can be used to weld many types of metals. The variety of electrodes that can be used in SMAW allow for welding in a number of positions. However, industry is phasing out SMAW because it cannot be automated, and there are other welding processes that are more productive. In the 1930s and 1940s, advances in materials used for the electrodes made the process reliable and simple. SMAW became widely used during World War II to build military equipment. Companies quickly began making SMAW machines to meet the demand. Shielded metal arc welding is one of the world's most popular welding processes. SMAW is used to weld materials such as steel, cast iron, forged steel, stainless steel, and cast aluminum. However, SMAW is not used with some metals. SMAW is not used with titanium because fluxes combine with titanium and cause brittle welds. It is also not used with copper, brass, and magnesium because their low melting points make them difficult to weld without completely melting through the base metal. Gas metal arc welding, or GMAW, creates an electric arc to heat the metal, similar to SMAW. However, GMAW uses a continuously fed electrode wire that is shielded by a gas instead of a flux-covered stick. A GMAW system uses a welding machine that has a wire spool and wire feed mechanism. It also includes a work lead, gun, and gas cylinder. Wire drive mechanism. GMAW welding machine. Gas cylinder. Gun lead. Gun. Work lead. In the GMAW process, electric current from the welding machine creates an arc as it jumps the gap between the workpieces and the electrode wire feed from the torch. This arc creates heat to melt the metal at the joint. Both the wire electrode and a shielding gas feed through the torch. The gas shields the process from contaminant gases in the air. In addition to acting as an electrode, the wire also provides filler metal, so it is consumed during the welding process. In GMAW, the wire is fed continuously from the wire spool when the operator presses the trigger on the torch. Pressing the torch trigger also feeds the shielding gas to the weld. The gas is fed from one or more cylinders through the torch nozzle. The gas is a mixture of argon, helium, carbon dioxide, oxygen, hydrogen, or nitrogen. The type and quantity of gases mixed depends on the application. GMAW is often called MIG welding. MIG stands for metal inert gas. This name comes from the fact that GMAW welding first used inert gases for shielding. An inert gas is a gas that does not combine chemically with other elements. Today, GMAW welding can be done using gases other than inert gases, such as carbon dioxide. Therefore, MIG is not an entirely accurate term. Even so, MIG is the most commonly used term for this type of welding. GMAW or MIG welding can be used to weld steel and most other metals. With the right settings, it can be used on most thicknesses of metal. The continuously fed wire eliminates the need for the operator to stop and replace electrodes. Therefore, it is well suited to applications in which welds need to be made quickly. Unfortunately, a slight breeze can blow away the shielding gas and cause weld contamination. This makes weld quality hard to control in outdoor settings, so GMAW is most often used indoors. GMAW welding is the most common type of industrial welding because it is fast and versatile. Choosing the right electrodes and shielding gases can make it effective on almost any metal. GMAW is used in the fabrication of structures, shipbuilding, pressure vessels, tanks, general and heavy electrical engineering, and the aircraft engine manufacturing industries. GMAW is also used in auto parts manufacturing, auto repair, RV repair, heavy equipment repair, and pipe welding. What is the name of the flux-covered rod used in SMAW? What welding component melts and turns into a gas that shields the weld from air? SMAW can be used to weld which material? What is another name for GMAW welding? In the GMAW process, what is used to shield the weld? What is another name for SMAW welding? Gas tungsten arc welding, or GTAW, uses an electric arc to melt the metal and a shielding gas to protect the weld from contaminant gases, similar to the GMAW process. Unlike GMAW, GTAW does not consume the electrode. The tungsten electrode can withstand welding temperatures without melting. A GTAW system consists of a welding machine, gas cylinder, work lead, torch with electrode, and filler rod. In the GTAW process, electric current from the welding machine creates an arc as it jumps the gap between the workpieces and the tungsten electrode attached to the torch. This arc creates heat to melt the metal at the joint. Shielding gas feeds through the torch to protect the weld pool from contaminant gases in the air. Like oxyacetylene welding, most GTAW applications require the welder to feed a filler metal into the weld with one hand while using the torch with the other. In GTAW, filler metal often comes in the form of a rod that is added to the weld pool by hand. However, some applications use a continuous feed filler metal, which is stored on spools or coils. Filler metals are available in many diameters and are made of various materials. The GTAW process also needs a shielding gas to protect the weld from contaminants. The shielding gas is usually 100% argon. It is fed from a gas cylinder through a hose on the welding lead to the torch. Gas tungsten arc welding is commonly referred to in the welding field as heliarc welding or TIG welding. Heliarc refers to a specific brand name of welding equipment. TIG stands for tungsten inert gas. In the job market, both heliarc and TIG are terms used in place of GTAW to describe the same welding process. One advantage of GTAW is precision. GTAW allows the operator to weld thin metals without melting through the metal. It is capable of forming a precise arc and is more accurate than SMAW or GMAW. The disadvantages of GTAW are that it is very slow and can only be used to make horizontal welds. GTAW is the most often used welding method in airplane production and for welding thin pieces of stainless steel and light metals. It has become very popular among airplane and race car hobbyists for their projects. This welding process is not used in many mass production manufacturing applications because it is slow. Imagine trying to use a small trim paintbrush to paint an entire wall. In addition to oxy-fuel and arc welding processes, another common group of welding processes is resistance welding, or RW. Spot welding is the most well-known type of resistance welding. A spot welder consists of a power supply and two arms with electrodes. One arm is movable and the other is stationary. A spot welder uses two electrodes to concentrate an electric current into a small spot. The current passes through the parts of the workpiece for a precise amount of time. Forcing a large current through the spot creates heat, which melts the metal to form the weld. This allows a bond to form without heating the surrounding metal. No flux or filler metal is used with spot welding. The advantages of spot welding are many. It is quick and easy. There is no need for fluxes or fillers to create the weld. There is no open flame to cause safety issues. Spot welding also has disadvantages. Some weld positions may not be easily accessible because the spot welding electrodes must be able to reach both sides of the metal being joined. The equipment cost is high, and it works on only thin metal. Spot welding is used for production processes because it is very fast. A robot can be easily set up to make spot welds, so many industrial robots found on assembly lines are spot welders. Spot welding is used to weld car body parts, filing cabinets, and other sheet metal products. Robots in automotive factories can produce a weld in about 100 milliseconds, or 1/10 of a second. A robot can be easily set up to make spot welds. The shielding gas in GTAW is usually 100% of which gas? Spot welding is used to weld car body parts. GTAW is used for applications where accuracy and appearance are of key importance. When a spot welder squeezes the metal to be welded between two electrodes and passes a current through them, what is created? GTAW produces which very precise electric components? Unlike GMAW, GTAW uses a non-consumable electrode made of which material? In which types of welding applications is spot welding used?